Hi everyone, today I will be showing you a hook that is meant for a grade 5 class. This hook was designed for the strand Understanding Structures and Mechanisms, specifically forces acting on structures and mechanisms. The overall expectation this hook will meet is to investigate forces that act on structures and mechanisms, and the following are the specific expectations it will meet. To analyze the effects of forces from natural phenomena on the natural and built environment, to follow established safety procedures, to use technological problem-solving skills to design, build, and test a structure that will withstand the application of an external force, and to describe forces resulting from natural phenomena that can have severe consequences for structures in the environment and identify structural features that help overcome some of these forces. I hope you enjoy the video. Good afternoon, grade 5s. Today, we're going to be talking about external forces and the impacts they can have on structures. An external force is a force that comes from outside of a building's internal structure. These could be natural disasters or other impacts. For example, a hurricane, earthquake, a tornado, or snow that sits on a roof are all external forces. These forces can cause damage, which is why it is so important that buildings are built to be resistant against them. We're going to do an experiment using these structures to see which one will be the strongest and most resistant against wind, as well as snow that's sitting on its roof. These three structures were built very similarly. Each consists of 4 vertical columns that are held together by horizontal beams. Structures A and B were built with a very brittle and thin noodle called capellini. The difference between these two is that structure B also uses cross bracing, which you can see forms an X. Structure C is identical to structure A, except it was built with spaghetti, which is twice as thick and 3.5 times heavier. I've placed a sheet of paper on the side of each structure to represent the side of a building. I will use a hairdryer to simulate wind against the side of each structure. Which do you think will be the most wind resistant? A, B, or C? Structure B is the most wind resistant, and structure A has the least wind resistance. Now we're going to conduct another experiment where we will determine how each structure reacts to the force of gravity by applying different weights to the tops of each structures using these plates that weigh 1/2 ounce. Which one do you think will withstand the heaviest load of rice? Now we're going to test structure A, and we're going to see how well it can hold 2 ounces of rice. Let's see. So we can see it's pretty wobbly, and if we put any more on, it will likely collapse. So now we're going to test structure C. And because we know that structure C was built with a much stronger material than structure A was, we're going to start out with 6 ounces. So we can see it holds 6 ounces pretty well. So let's try to replace the 6 ounces with 10. Oh, so it holds 10 ounces, but if I add any more, it will likely collapse. Now that we have seen structure C can support 10 ounces, let's see if structure B, which is built from a much thinner and much lighter material with the addition of cross bracing, can also withstand 10 ounces. It's standing very well. Let's try to add another 6 ounces. It's still standing very well. Now let's add another 4 ounces, which adds to a total of 20 ounces, and it's still standing strong. The cross bracing was the key to this structure B's success in both experiments. Cross bracing is used in real-life buildings to resist the damaging effects of external forces. The 2 diagonal braces that form an X will support one another by pushing against the vertical columns preventing them from bending when facing forces from any side of the structure, as we've seen in our previous demonstrations. Cross braces are the stabilizing system of the structure. While the horizontal beams on the structures hold the vertical columns together, the stiffening of the structure is done by the cross bracing. Thank you for watching this video.